How did calculus begin? Imagine trying to understand how things change in the world around us. From the way planets move to how a car accelerates, early thinkers wanted to find a way to describe this change. That curiosity led to the birth of calculus, a branch of mathematics that studies change and accumulation. But how did it all start? Let's take a journey through time to see how this powerful tool came into being. Long before calculus was formalized, ancient civilizations were already exploring ideas related to shapes, motion, and quantities that change smoothly. Around the 4th century BCE, Greek mathematicians like Eudoxus created the method of exhaustion. This method involved inscribing polygons inside shapes to approximate their areas and volumes more and more closely. Think of drawing many-sided polygons inside a circle to get a better idea of its size. This approach was a big step toward understanding limits, which are essential in calculus. Later, the famous Greek mathematician Archimedes expanded on these ideas. He used the method of exhaustion to find areas of curved shapes like circles and spirals. He also worked on tangents to curves, which are straight lines touching a curve at one point. These ideas hinted at what we now call derivatives, which measure how fast something changes at a specific moment. Archimedes broke down complex shapes into tiny parts, a concept similar to infinitesimal, tiny quantities that are almost zero but not quite. As time moved on, progress slowed in Europe but continued elsewhere. In the Middle East and India, mathematicians kept pushing these ideas forward. Ibn al-Haytham, for example, used formulas to calculate volumes of curved solids. The Kerala school in India explored infinite series, which are sums of infinitely many terms. These series are fundamental in calculus because they help approximate functions and solve problems involving change. The real breakthrough happened in the late 17th century when two mathematicians, Isaac Newton and Gottfried Wilhelm Leibniz, developed calculus independently. Newton focused on understanding motion and change through his concept of fluxions, which are like derivatives. Leibniz created a notation system for differentiation and integration that we still use today. Their work linked the ideas of how things change instantly and how quantities add up over time, forming what is called the fundamental theorem of calculus. The word calculus itself means small pebble in Latin. Back in the day, people used pebbles for counting and calculations. This name reflects how calculus involves tiny, almost infinitesimal pieces to solve big problems. Since then, calculus has become vital in many fields, from physics to economics to engineering. Its roots show how humans have long been fascinated with understanding the world through numbers and their meanings, gradually building a system that helps us describe the continuous changes around us.